Hi everyone, I'm Professor Sally Eaves, Chair of Cyber Trust at the Global Foundation of Cyber Studies. It's my pleasure to speak today with Stephen Douglas, who is Head of 5G Strategy at Spirent Communications. Welcome, Steve.
Thank you, Sally. It's great to be here again.
And likewise, always such a pleasure. And such an interesting topic area for us today, I think, all things 6G. Although we're still at this kind of early vision forming stage, I think the industry is also starting to coalesce around some key topic areas and ambitions too. So I'd love to drill straight into that. So from your perspective, Steve, why does 6G seem to be on people's radars so much right now when 5G in many ways is still in its infancy too?
Yeah, to be honest, Sally, I don't think it's to be unexpected. I mean, cellular generations, like 3G, 4G, 5G, they tend to take an 8 to 10 year cycle from that vision setting through to the study items and requirements and then gradually commercial availability. I think the big difference this time is really government and marketing. I think governments focus on connectivity technologies as key enablers for economic stimulation, for global leadership. And also, this need now to protect critical national infrastructure is creating sort of an unprecedented focus in funding. And this, we're already seeing billions of dollars in government funding now being allocated. And we saw an early sort of implication of this in 5G, where we saw some early funding coming into, but now in 6G we're seeing these mega funding roadmaps coming from China, the US, Japan, EU, Korea. And of course, the other area is the cheerleader in the room is the marketing and media side of the industry. And of course, it's inevitable to future gears, especially when 5G still is in its infancy, and the benefits are currently not that easy maybe to be seen. And we saw this before with 4G, so I'm not that surprised.
Absolutely. I think it kind of goes along as well with this general kind of heightening around digital transformation and convergence that we're seeing as well. This kind of future scanning really fits into that overall landscape. So great perspective there. I'd love to explore a little bit more as well around what you're seeing as some of the early 6G use cases and the capabilities this can bring.
Yeah, I think as you said at the very beginning, we're still at that early vision forming stage of 6G, but the industry is certainly coalescing around several key sort of ideas and ambitions. And I think one of the grander ambitions, Sally, for 6G is to combine the physical, digital, and the biological worlds into this realms of communication to enable things like holographic, tactile, and even physiological driven communication, where our sensory inputs, outputs like touch and feel can be transmitted as we do today with voice and video, enabling a new range of human machine services. And that's going to bleed into things like intelligent skin level sensors, which may revolutionize healthcare monitoring. For example, we're already seeing discussions around needle free blood sampling for early disease detection and even pandemic tracking. The other area is digital twinning. I think this is another area of great interest where highly accurate and synchronous digital representations of physical entities are going to become more critical to optimize decision making, design, and operation, especially for complex systems. Now, of course, to realize all these ambitions, the industry is looking already to set new targets such as data rates and speeds, such as 1 terabit per second, which is 100 times faster than the ambition of 5G today, and even latencies as low as zero point 0.1 milliseconds, which would be sort of 10 times lower than we're hoping to get with 5G. But I think the truth of the matter is that at this stage, of the vision setting, these targets are mostly aspirational, and we really need to research and discover what metrics really make sense. And I think we may even conclude, over the coming years that we actually need new types of metrics, such as trust, quality of life, and sustainability, rather than just speed and latency.
So true. That's a really interesting point. I think, trust, kind of biggest currency of our time in so many ways, and sustainability. I'm heading to COP26 very shortly. I think your suggestion there, we could do things around air quality measurement, for example, around gas, around toxic gases and sensing, for example. So I think so many new areas to be explored around those metrics as well. So super interesting that. And to kind of enable all this, the tech foundation, if you will, what new tech and architectural capabilities will be needed to support 6G?
Yeah, I think one thing that is becoming clear is that 6G is really going to be an amalgam of complementary technologies coming together to deliver those use cases and value. And if we look at some of those technologies, one area of exploration today is around opening up the sub-terahertz radio frequencies, using things such as narrow pencil beams and really highly directional antennas to deliver these extremely high data rates for the communication. And The interesting thing about this radio frequencies at these higher frequency ranges is that they can also enable things such as radio sensing to provide techniques to actually measure the environment, detect and even recognize objects. There's other concepts called subnetworks which are coming about at the moment, and this is driven by the need for special purpose, localized networks for all of the vertical industries. And these specialized subnetworks could be in the millions, including even our body. Sort of body area networks where an in or on body subnetwork of small, low powered wireless sensors could be used for everything from monitoring our health as well as sensing the surrounding environment that we're in. And then one of the interesting ones to me is this exploration around reconfigurable intelligent surfaces. And this is really to help amplify and redirect the radio signals to provide coverage to really the unreachable areas. And now these smart surfaces, which will have many small antennas and use reflecting metamaterials, are going to offer us the capability to not only redirect, but also to amplify the radio signals to reach those sort of awkward positions we can't get them today. And I would expect you'll see that start to cover a lot of our materials and our buildings, our cars, everyday objects, all encompassing these reflective environments, which have zero or near zero power consumption overheads. You also have the continued, I think, evolution of AI and machine learning in our networks as we really try to evolve to cognitive, self-driving, self-healing, self-protecting networks. And then finally, sort of quantum's coming into the mix as well. Quantum optical communications to create virtually unhackable ways to protect the communication channels, and quantum in our data centers to really deal with the overheads of processing of AI in a real time fashion. So in essence, we're really creating a network of networks is what 6G is going to be all about.
I love that. So many points there, kind of this age of convergence, the embedding security you mentioned at the end there. But I love that one about smart surfaces. I think the benefits there, whether you're looking at energy consumption or also closing connectivity gaps in the rural last mile, for example, so many things to look at there. And the body aspect as well, true hybridity, it's a term that's used a lot, but in that particular sense, it's a whole new level, isn't it? That's fantastic. And so again, looking at the enablement opportunity of making this happen, what learnings can we take from the 5G experience to help deliver this trajectory ahead?
Yeah, I think there's two key areas that have came out of our learnings from 5G. And the first is really about engaging with industry and enterprise from the start of the vision setting stage to better understand their requirements and their challenges. 5G, to be honest, left it very late in the day to talk and engage with industry, meaning we're only going through that process now, even though the 5G system is now commercially available. I think second is really to factor in the practical nature and affordability, simplicity, and manageability of a 6G system at the earliest stages. With all that early 6G excitement around the potential, capabilities and use cases, it is definitely easy to overlook things like service delivery costs, ease of operation, which actually may ultimately define the commercial success or failure of the system. And this means that we need to sort of focus on early research work to assure that the desires of 6G innovation are also grounded in the practical realism of how you deploy, operate a decentralized and incredibly dense network of networks. And I think this is where you're seeing things like distributed AI, machine learning, and extreme automation being touted as the fundamental capabilities of the 6G system to help deliver on that. But to be honest, AI also needs to be trustworthy. A black box needs to be explainable. The inability of us humans to see inside black boxes, unfortunately, can result in AI adoption being hindered. So I think new areas around governance and trust of AI will have to become sort of the new areas of the operational support systems to really drive that adoption.
I couldn't agree more. Trust is an imperative, isn't it, to adoption? Absolutely. And compliance and governance, I think AI will have a huge role to play there, particularly reducing the complexity that we see around that area as well. So excellent point, Steve. That's brilliant. And kind of gives me time to ask one final question. So will 6G be the last G? I had to ask that. It's a fantastic one when we look at the iteration we've had over these different levels.
Maybe I think as many in the industry would like it to be. I think we're moving to network of networks with cloud native agility, open network developer ecosystems, and we're moving gradually away from that generational approach of a big transformational release and heading towards more continuous and rapid iterations with loosely coupled federations of transient sub-network developers. So does it make sense to call it another G or generation? Are we really stifling innovation by doing that? I think maybe the challenge is more to do with those who fund or those who market it. I think they like an incremental release. It's a good way to promote added value, and I think that's maybe why, unfortunately, you probably will see a 7G and 8G. I would also argue maybe it's time to also ground ourselves back a little bit into 5G, which really still is in its infancy. We've got another four, probably more major releases of standards coming out. It will be the evolutionary pathway to 6G. And probably in the second half of this decade, in the 5G advanced system, we'll even see some of these early 6G capabilities come into it and use it as an evolutionary playground.
Fantastic. I love that. So I think it's a definitely maybe. I think I'll take it as that, Stephen. That's fantastic. And honestly, I think it's such a clear and really compelling, I would say, overview of the 6G landscape ahead and different points that we consider right now and why it's important to have that dialogue right now and to close those gaps and bring ecosystem collaboration to the fore to make the best of these benefits that we can afford. So thank you so much, Steve. Honestly, it's a pleasure to speak to you. Thank you for your insights.
Thank you, Sally.
Look forward to speaking soon. And to everybody as well, thank you very much for watching. More information coming soon.